I'm happy to introduce Lars Weiler to you, who's going to speak about data analysis in Terabit Ethernet. Lars, please.
Yes, thanks. Hi, and thank you. As you said, Lars Weiler, my name. So I'm from Cologne. And during the last few years, I worked for the company Magellan Netzwerke. It's a company in Cologne where I set up and build up some networks with analysis, and especially in terabit or at least gigabit analysis, but it's also possible to do terabit Ethernet analysis. So we have three main parts. The first part, I will introduce you to the name of the data mediation layer. It's a quite new thing to data analysis. The second part is about the monitoring, and in difference to surveillance, what's the difference, and well, what you can do nowadays without data retention, so how it's possible to capture data or how to identify persons without data retention. And the third part is a deeper view about the devices itself which are used, so like about the security of the devices and where are the problems. Let's start with the first part, data mediation layer. So in the background you can see a couple of devices. I will tell more about them later in this presentation. Let's go back a little bit into history. Probably you know this, telephone tapping. It's a word, so tapping, which you probably might know from home. If you want to listen to a phone call from a sister, just go to your parents' sleeping room and pick up the phone and listen to the phone call. You might probably also know this from some bad movies or so. There were also some people in the past who can listen to phone calls, like these telephone operators, those ladies who picked up the call and set up the connection to another person. Later on, there were devices at the telephone companies where they can record also the phone calls for later analysis, or if they want to find a person non grata for listening to what they are saying, or if they have problems with something. Anyway, let's go to a network. Probably you might know this or remember this. This is a 10-base-5 Ethernet cable, thick wire or yellow wire. If you want to set up a computer to the thick wire, you had to use some clamps. They were called vampire clamps or vampire tabs. Because of their layout, you had to use a thing, that's the thing in the middle over there. And it had some clamps in which looked like the teeth of a vampire. You had to push it into the cable and you can plug in another client. So everything on the cable was on every computer. Later on, we had some more bus technology like hubs. Probably you might remember this. You can listen to every connection or everything on the network. And furthermore, wireless internet. So the wireless internet, which isn't encrypted, you can see every data on it. So if you plug in a computer into a hub or into a wireless network, you can just open your analysis product, like this slide, it's Wireshark, and see all the data which flows by. There are also some more analyzers from other companies. For example, the first analyzer, network analyzer, was built by Wild Packets. It was called Etherpeak. Later on, they renamed it into OmniPeak. There's also a product from NetScout, InfiniStream, or the Network Instruments Observer, and some more products for intrusion detection or intrusion prevention systems, like Snort, Sourcefire, Juniper, or something like that. These products will not be the main part of my presentation. I want to introduce something else. So you have a problem later on if you want to monitor full duplex traffic. For example, this bus technology is a little bit is quite easy to monitor, but if you use full duplex traffic, you have a switching traffic, you have direct connections from one client to another client, and you have to find something new what you can do to monitor the traffic in it. If you use optical fiber cables, you have full duplex. So if you, or in the optical fiber, you have one link from one direction to another direction. And so you can also get full bandwidth for the complete, traffic. And furthermore, you also have 2 gigabit, or if you have 1 gigabit fiber cables, you will see a complete 2 gigabit traffic on the complete line. So the problems here that you have to find a way to send out the traffic in the fiber cable. You can do this with a splitter. Probably you might remember this from physics or so. You can split light. If you use a device like a prism, like shown in this slide, you can distribute the traffic from one light ray into 2 light rays over here, so that you can send out data onto 2 different cables. There's also a possibility to set up split ratios in this cable, like, you can send out 50% to 50% of the light to one machine or to another machine, or you can also have another split ratio of 90 to 10 or so. It's quite handy if you have a connection and want to set up an analysis machine. So you build this splitter into your connection, and then you can send out all the traffic to another machine. I will show it later in some more slides, so how it's possible. The disadvantage is that you have to do this for every line, so for every direction. As I said in the previous slide, this is a full duplex connection. You have to build in such a splitter in each of the directions. So if you want to see the whole traffic, you have to use 2 splitters, and you have 2 network connections for your analysis. It's a little bit easier with switches. With this copper switch, you can set up something like a span port. It's a switch port analyzer or mirror port. You can do this in software. It's quite easy, so that you send out the traffic from one port to another port, and just use your analyzing machine to see what is on this port. The advantage is that you don't have any connection loss if you set up an analysis port. With optical fibers, you have to disconnect the line and build in this tab, and later on you can use the line again. There's a disadvantage. If you use full bandwidth, so full duplex traffic, you have 2 directions, and if this is a 1 gigabit connection, it's possible that the combined traffic will be, or will extend those 1 gigabit of the analysis port, so that you have so-called oversubscription of traffic. That means some traffic will be lost probably. Or you have to mirror it on 2 ports. It's also possible. So let's see, data analysis. What is it? So there's a server, there's a client, and you want to see the traffic on this or on this connection. You just can set up a splitter in a fiber connection and connect it to your analysis machine. So in the upcoming slides, I will use this Wireshark symbol just for the analysis machine. Quite useful for it. So in this case, you can use a splitter, or you can also use a switch with a span port. The advantage of a span port is that you can also connect a second client and see all the traffic to the server. This is quite easy. It's a quick setup. But if you change a little bit the setup, like you have a setup of a couple of routers, and you want to see the traffic from all the connections in here, so all the yellow lines, you have to build in a lot of splitters, and you have a lot of, or you need a lot of network cards or network ports on your analysis machine to combine the traffic and see all the traffic on all those lines. It's probably easier to set up a couple of analysis machines with the disadvantage that you can't see asynchronous traffic, for example. So if there's traffic which runs around somewhere in the switches and takes different connections, it's quite difficult to combine all those connections for analysis. Well, let's replace all those different analysis machines with this black box and just connect one machine, one analyzer to this black box, so that the black box will be helpful with the analysis, so combine the traffic or do something else. If there's still so heavy load on this connection, you can still use a couple of analysis machines and distribute the traffic to those machines, or use filters. For example, like all HTTP traffic should go to the machine in the top and every other traffic should go to the machine in the bottom. This simply is the name, or this will be named the data mediation layer. It's a quite new approach to change the connection, or to capture the traffic, I would say. Well, let's look a little bit deeper into this box, or into this black box. What can it do? There are four main tasks for this black box, for this data mediation layer machine. The first task is aggregation. Aggregation means that you combine a couple of lines into one, as we saw on the previous slide, so that you can use all 5 lines and combine them into one line, aggregate all the traffic. There's one problem with it. It's the so-called oversubscription, as I said earlier, about full duplex lines. So like we have 1 gigabit line, the maximum traffic will be 5 gigabits. We don't have a cable with 5 gigabits, so we have to find a way to resolve this. We can use 10 gigabit lines, or we can also do something else, filtering out like that. The second task is the regeneration of traffic. That means just copy traffic from one line to more lines. So we have one port and we want to copy the traffic to a couple of more ports for more analysis machines. For example, analysis machines which will do different tasks. The one will look into HTTP traffic, the other into email traffic, or something like that. The third task is distribution. That means that we can send out traffic from one incoming port to a special tool port, or from a couple of incoming ports with aggregation to another tool port. And the last one is filtering, so that we can filter out traffic for special tasks. The filters on these black boxes are working on OSI layer 2 to 4. That means we can filter out MAC addresses, we can filter out IP addresses, we can filter for ports, UDP, TCP ports, and a lot of other bits in TCP or UDP headers are also filterable, so acknowledgement headers or bits or something like that. The best thing is to do the to combine all 4 tasks, like that we can aggregate traffic in this black box, do a couple of replication or distribution, and filter out everything what we want or what we don't want. And there's also a 5th task now, which is quite new. This is manipulation of data. There are 4 subtasks, I would call them. It's first one of manipulation is packet slicing. That means that you can slice the body of a packet and just use the header. It's quite useful if you just want to see the type of traffic on your analysis machine and don't want to look into the body itself. The second one is masking. That means that you can overwrite a couple of bytes inside the packet itself. This is used, for example, by banks, so financial companies, which want to overwrite the accounting data in their bits and bytes. The third one is timestamping. That means that they will add another header to your packet with timestamps on it, which are working on nanoseconds, so that you can do analysis in nanoseconds and see how long a packet takes to travel a line. It's quite useful for the analysis of connections itself, where's the problem, which line is slow, or something like that. And the fourth one is source labeling, so that you can just add another header for the incoming port, on which port a packet runs through. It's useful for, probably you remember the slide with those 4 routers and 5 connections, so you can see which line has been used for a special type of packet. The manipulation is done in real time. There's no delay in it. And you don't even see it on your, you don't even recognize it during your analysis. Well, let's identify the vendors. This shouldn't be a product presentation or something like that, but I just want to tell you the names of the vendors. I will quickly step through the slides, so just that you can remember it or that you see what these machines are or how they look like. There's 3 main vendors which can do Terabit Ethernet analysis, and they all produce machines especially for 10 gigabit ports, and they also, or some of them also announced that they can do this with 40 or 100 gigabit ports. First one is Gigamon. This one has been introduced it has been founded in the year 2003, and they released their first product in 2005. They are based in the Silicon Valley. And this was the first machine with a 10 gigabit port in it. So the first machine had 10 gigabit ports. This one has 4 10 gigabit ports and a couple of 1 gigabit ports. The current machine or the current flagship contains 24 gigabit ports, so you can aggregate 240 gigabits in one machine without any delay or something like that. They contain they contain a CPU from Freescale, so it's a PowerPC-based machine just for the operating system, which is ECOS. It's an embedded open source operating system. And the filtering of packets is done by this complex programmable logical device, or CPLD, from Altera. And it's possible to stack those machines. You can combine 23 of the big boxes, which means 23 boxes with, well, 23 ports, because you have you have to use one port as a stacking port. That means you can analyze 5 terabits of traffic within no time. Well, second one. Second one is VSS monitoring. It has been also founded in 2003, and they also released their first product in 2005. These are, so VSS and Gigamon are the most active competitors in this marketplace. But they started with small devices like this optical fiber tap. This is just a prism image, and you can send out the traffic from fiber line to those monitoring ports on the right. They also have small devices for copper lines, and bigger ones with 10 gigabit ports on the left here. You see those XFP ports and a couple of 1 gigabit ports. This is their flagship with 24 10 gigabit ports. And this one is a quite nice boy. This is a protector or object finder. It has been built for filtering only. So you can plug in a line and filter out emails. You load up or you upload a text file with email addresses. It can contain up to 64,000 email addresses. And it will filter out every traffic or every packet with this email address within no time. It's not related to email only. You can also filter out instant messenger traffic, at least if there's an @ sign in it. So the first 25 boxes has been sold to the FBI. Well, these machines are based on an ARM CPU, and they are running Linux on it, of course, with violating the GPL. And they're using a FPGA from Xilinx. And finally, those boxes are also stackable, like the devices from Gigamon, so that you can also simply analyze terabit Ethernet traffic. Well, third vendor, this is Appcon. They have been founded in 1993, so a long time ago. But in the past, they produced layer 1 matrix switches so that you can just connect a couple of lines on layer 1 layer, or on the layer 1, like network cables or telephone cables or even SCSI cables. In 2009, they introduced a machine for terabit or for gigabit Ethernet traffic analysis from 1 unit to 8 units. There are 96 ports on it with 10 gigabits. So it's roughly 1 terabit in one machine, which you can analyze. They're also based on an ARM CPU. They're also using Linux, and they don't say it. And they also use the Xilinx FPGA for the filtering part. So, what are the benefits for such a setup, for this data mitigation layer setup? The first benefit is the cost. You don't have to use many analyzers. For example, you don't have to use a couple of 10 gigabit analyzers. You can also use 1 gigabit analyzers if you filter out a lot of traffic and just focus on the traffic you really want. You you can still use your old analyzers and don't have to buy new ones, but you have to buy these machines, those black boxes. You can also monitor more network ports. You don't have to set up an analyzer on every connection, but you can just combine or aggregate all the connections in these black boxes to one monitoring cable or analyzer. Furthermore, you have less load on the analyzer. So probably, I think you all played around with Wireshark, set up some filters, and had a huge load on your network card. You will see after a short time that your CPU will run on 100%. If you filter out every traffic you don't want, your analyzer won't be so busy. That's a big advantage. You don't have any data loss. You can just focus on the traffic you really want. In the past, there was the term of capture and decode everything. So just capture all the traffic, store it on your hard disk, and decode everything later on. Nowadays, you can set up your filters and analyze only the traffic you really want. There's some more advantages, like for test setups. If you have a laboratory for testing your connections or something like that, you can quickly change your connections without reordering your cables. You can do it in software. Just say which line should be monitored on which analyzer. You don't have to go into your laboratory and plug out and plug in the cables. Okay, first part done. Second part, monitoring versus surveillance. I guess you all know this. Monitoring, what is it? It's simply monitoring your traffic or monitoring your connections, your lines you have, or your devices if they're still up, if they're still running. And you can also monitor the data or the amount of traffic of data which is running through your lines. Monitoring is, well, I would say more or less anonymous. So you don't look so deep into your traffic that you can identify your users. You're just interested in numbers, how many users, how high is the traffic, or something like that. This is used mostly by, well, I would say mobile phone operators. Those companies, Germany, we have 4. It's also used in the financial market. They just want to make sure that their data is running, or their money, because money is nowadays just a couple of bits. And it's also used by internet providers, of course. And there's surveillance. Surveillance looks more onto an individual. So it identifies a person. It's mostly used by lawful interception or intelligence agencies. And these are also the customers, like the 3-letter organizations, FBI, CIA, BND in Germany, or the Bundesstelle für Fernmeldestatistik, is the name in Germany. And it's also used by a couple of internet providers in countries without democracy, I would say, like the Middle East or Asia. They already bought those machines for identifying their users. Okay. If you want to identify your user, you have to use filter lists. In this example, it's a phone book. I think it's from San Francisco, because there's a prefix of 650. Probably you should remember this. I will come back to it later. But you have to use a filter list and see or identify your users by numbers, I would say. Well, some examples. If you want to filter out email, so you can just use an analysis machine, send your email, and this analyzer will see your complete email. If you use encryption, your mail server will be able to unencrypt the mail and read the content, but the analyzer isn't able because the analyzer doesn't contain the SSL key, and it isn't useful. But you can change your setup. So if you use an SSL terminator like this blue box over here, which contains a key, and you can use also a couple of mail servers over here. Use your black box and connect all your cables to the black box. Then you send an email, encrypted emails. Will be unencrypted in the analyzer or in the SSL terminator, and after that, it will be sent out unencrypted to your mail server. It's the usual setup at email companies. Also possible to do it with HTTP traffic or HTTPS traffic, so that the unencrypted email will be sent to the mail server and also to your analyzer. So it's still possible to analyze your content. Also, you used SSL. Well, another example. Probably you remember, we had data retention until February this year, at least over here in Germany. Then they dropped it. So internet providers aren't allowed to store all the data nowadays. But you don't need it. Well, we have, let's say this is an internet provider with a test concentrator over here and another router over there, and connection between. In this connection, all the traffic from all the users is combined to the internet. If we connect this line to our analysis box or to our black box, we can see all the traffic on this line. Now, user Oscar goes online, but we have a filter on it or a trigger on it that says if the user Oscar goes online, it should send out an alarm. For example, to another box, which will configure our black box over here and say, send all the traffic from the user Oscar to our analyzer. So now if Oscar sends some data, every packet will be also distributed to our analyzer, but only the data from user Oscar, not the data from Alice or Bob. It's also possible to filter out traffic to a special site, for example, YouTube. It's a real-life example from a state in North Africa. They want to filter out all traffic from YouTube so that they can find out which user or which citizen in this state or in this country will watch YouTube videos. So you can set up a filter for YouTube, and now every YouTube request or response will be sent to the analyzer. It's quite easy to set this up and just to analyze only this traffic. Okay. Third part. I would say the most interesting part about hacks and so on. Well, first a question, what's more interesting? Is it the content like this kitty over there, or is it the filter list we see in the background? I guess for government it's, should I stop? Well, I guess for government it's more interesting. Oh great, now you're awake again. Well, I guess for the government, it's more interesting to see the content. But for us, for hackers or freedom lovers, it's more interesting to see the filter list. So what is filtered? Let's say the filter list will explain what is filtered, and the content explains or probably explains why it is filtered. So I think our task should be to find the filter lists on these devices. And it's stored somewhere on the device. There's an SD card and they store the filter list on there. So we just have to get the SD card. I think it's quite difficult to do it if this machine is set up somewhere in a data location or so. But if you have the chance to boot such a machine, just use the serial line, plug it in, and see what is running on it, like this Linux. If you also have the chance to play around with it, you will see there's a bootloader on it, and that you can enable the debug mode so that you get a complete root access to this machine. In this example, this is VSS, and they also have a debug mode, but they set up a password. Interestingly, this was the prefix of San Francisco. You remember it probably from the previous slides. Well, the black boxes also have a web GUI. VSS and Gigamon use a JavaScript-based web GUI. AppCon use a Flash GUI. This one on the lower right, this is AppCon. This is VSS. This is Gigamon. And there are a couple of, I would say, security flaws in it. So they don't do checksums if you upload a new version of the software. You can simply alternate the files and send your own files onto it. It's quite interesting because they also use internal commands within the JavaScript to trigger some configuration commands. And with Gigamon, it was also possible to display the filter list even without a login. If you find such a machine somewhere in the internet with a management port connected, play around. Another idea is that you send the filter list from the configuration machine from a technician. Most of the time, these machines are stored somewhere in a data center, and they are administrated remotely from a technician. So if you find a way to send out JavaScript messages or JSON files even, for example, Gigamon uses JSON files for filter lists and so on, you can see all the files or all the filters. So it's possible. It's also quite useful to watch into the, or have a look into the binary, the firmware file. If you have a deeper look, you can find user accounts on the machine and even super duper user accounts which are undocumented. And you can even find passwords which are the same on each device they ever sold. Well, it's a quite new business and probably they will fix it later in the future, but nowadays you have open doors, I would say. Hey, what was my goal for this presentation? So first, introduce you the name of the data mediation layer that you can nowadays use a black box for aggregating your traffic, for distribution of the traffic, for regeneration and for filtering, and also that you can manipulate data for your analyzers. The second part, I talked about the monitoring and the surveillance, and that you can nowadays do lawful interception, or that intelligence agencies can do it without data retention. So data retention isn't needed anymore, but you can still filter out traffic and find a special user. And the last part, the deeper view, we heard a little bit about filter lists and what's more important, or what is more important, the filter list. And you got some ideas what you can do for finding these filter lists. Well, some time left for questions. The Herald will give you the microphone, I would say. It's the best thing.
Thanks very much, Lars, for this interesting talk. I'm sure there are questions. Yes.
Hi. What about PGP encrypted emails? Is there any kind of solutions for that?
Pardon? Again.
PGP encrypted emails.
PGP encrypted emails, no. But you can still see the headers. So, like the envelope of an email. And probably this is more important for the intelligence companies or the intelligence agencies to see who is talking with whom, not the content.
Hi. We as hackers, I think we don't like black boxes so much. So my question would be, you said these boxes are running on Linux and another embedded operating system. Can you say something about the implementation of the filtering? You described what techniques are used to filter and manipulate the traffic. Can you say something about the implementation they used?
The filters are looking like those filters you can do, or you can apply to TCP dump. It's quite the same. It's quite the same setup, I would say. Probably it is TCP dump. I'm not sure, so I can't have this deeper look into this machine. But I guess it's quite the same.
Right. Let's take a question from the IRC next.
Yep.
We have several questions. The first question is, what about, because you mentioned the terabit, where are the terabits generally in your presentation?
Terabit, well, it's the stacking of the machines. And if you stack a couple of machines, you can analyze terabit traffic. So it's aggregated traffic, of course. But if you have a couple of 10 gigabits or 100 gigabit lines even, you can see into all the traffic at the same time. For example, a small comparison. 10 gigabit, what does it mean? Or filtering one packet in 10 gigabits. If you use a haystack, so probably you know this, the needle in the haystack. The haystack contains around 1 million grass strokes or so. And if you want to find a needle in it, you have to go through, well, 14 haystacks for one needle. This is 10 gigabit within 1 second.
So another question here. You had on one of your slides, you had a box called SSL Terminator. Could you explain what this is and how does it work?
Sorry, I couldn't understand you.
The SSL Terminator you were talking about. Could you explain a little bit more to us?
What kind of machines is this, or?
Yeah. What kind of machine is it and how does it work?
Sorry, I don't get it. Probably can explain it later to me.
He's just asking, you in one slide you had this email setup with the SSL terminator, and what's the function of the terminator and how does it work?
What's the function of it? Well, it's just to unencrypt your traffic and distribute it to a couple of other machines for load balancing, for example.
Question answered?
So first to say, I'm a little bit disappointed that they don't even think about trusted platform machines on ARMs, which would be possible and easy to implement. Another question is, do you have any idea how you can filter traffic by geographical means? Let's say from San Francisco area to Berlin area or something like this. Is this implemented or is this left for future updates?
I don't think this is a task of the black box, but it's more a task of the analyzers. I think it's also possible right nowadays from other machines. Arbor is a company who already does this.
All right, another question from the interwebs.
I hope I interpreted correctly. How the heck does it encrypt, also it, I guess, is a black box, the traffic without the client noticing?
It's already too loud in here, so I can't really understand.
One more time. How the heck does it encrypt, also it, the black box, encrypt the traffic without the client noticing, or without the client noticing it?
It's not possible. So I can.
How does it,
Sorry.
the black box, how does the black box decrypt data without the client noticing? I think that was the question.
The black box can't decrypt the data. It's you have to use a decryption machine before it, in front of it, so like a SSL terminator or something like that. If you send in encrypted data, the black box can't handle it. It's also funny side part for this email encryption or for this email filtering. You can only use POP3 and SMTP, but if you use IMAP, the machine won't recognize it.
You talked about the interception of traffic, but are the solutions available to block internet traffic like these?
Blocking the traffic, exactly?
Block gigabit traffic. So in this case, the traffic is copied over and is analyzed,
Yep.
but can the same solutions be used to block the traffic on certain parameters?
I don't think so, no.
There aren't any solutions available for that? No?
I don't know any, so probably there are solutions, but I don't know any at the moment.
Yeah.
Okay.
Who was the commenter just now? Okay, can you please wait for the mic?
I'm under the impression that they're doing it in New Zealand some way or the other, especially web traffic, HTTP. So maybe I'm wrong, but I think so, yeah.
Okay.
All right, any more questions from the audience? I can't see any. Any more questions from IRC?
Maybe, also just a comment, also a lot of people were hoping that you would have explained more the Terabit, how the network works, the Terabit network.
Was a question of time. It's a topic you can talk about a couple of hours even. So if you want to meet me, just send me an email or give me a phone call over here. I will stay here for a couple of more hours. So it's a really big topic.
You would have 10 more minutes.
Okay.
All right. Anything else here in the room? I don't see. All right. Then let's thank Lars again for the interesting talk.
Thank you.